Hello everyone, my name is Bisham Patel and I'm back with a short video on understanding test failure modes. In part 1 of this video, I'll be going over the requirements that the electrical safety test standards outline for a failed product during testing. I'll cover the importance of setting both high limit and often overlooked low limit values. These limits help you perform a valid test and avoid false passes. In part 2 of this video, I'll demonstrate how electrical safety test analyzers can detect both high and low limit failures for various electrical safety tests. If you would like to review more of these tests, I highly recommend watching our previously posted videos where we will introduce each type test. The safety standards provide a clear guideline on what constitutes a failure. What is important to note here is that these are minimum necessary values that should be considered essential aspect of product safety. Manufacturers can set their own limits in order to identify products that meet and exceed the standard. For example, during an electric withstand or hypot test, IEC 60335-1 considers a breakdown as any current that exceeds 5 mA for appliances or 30 mA with appliances with high leakage current. This essentially gives us the high limit that's needed to be programmed into the test equipment. In order to pass the hypot test, the current must remain under 5 mA or 30 mA high limit. A test is considered high limit failure if the current ever exceeds this value during the test. Now let's take a look at the low limit parameter. This value doesn't come from any standards, but something that should be considered by all manufacturers. In an event that test cables aren't connected properly, or if the test equipment malfunctions, this can result in no current being measured by the test equipment, creating what's known as a false pass condition. Setting the low limit indicates that you expect a certain amount of leakage current for a device on the test. At the minimum, the leakage current should exceed this low limit value in order to be considered a valid test. Next, let's take a look at limits for ground bond test. IEC 6060-1 requires that the resistance of ground circuit be below 200 milliohms. This gives us our high limit for ground bond test. In order to pass the ground bond test, the resistance has to be under 200 milliohms. If the resistance exceeds this high limit parameter, this is considered a high limit failure and the ground bond test has failed. If there are types of shorts between the test cables or equipment malfunctions, the ground bond resistance will read a small value. For example, below 25 milliohms. While ultimately this small value is desirable, the low limit parameter can be utilized in order to flag measurements that are well below an average value for the given test. Next, let's take a look at installation resistance test. UL 60950-1 IT equipment standard requires that the installation resistance value be at a minimum 2 megaohms. Since we're given a minimum value to meet, the low limit parameter becomes the gauge for passing or failing a test. The IR value must exceed a minimum value in order to consider a pass. If an IR value falls below this low limit during the test equipment will display a low limit failure, and this is considered to have failed the installation resistance test. To avoid any false passes, the high limit parameter is set for the resistance test. Having the test lead not connected properly could result in an open circuit or a very high resistance value. Again, desirable but an invalid test. The equipment will display a high limit failure. For leakage current testing, the standard 60601-1 requires a certain leakage current value to be below 500 microamps. Again, this gives us the high limit value which should not be exceeded in order to be considered a pass according to the standard. If the leakage current is exceeded during test, the equipment will indicate a high limit failure. A low limit can be utilized in order to have a valid test. If the line leakage current does not meet the minimum amount set by the low limit, this could be an indication of incorrect setup, malfunctioning measuring equipment, or a faulty product being tested. In the second part of this video, I'll be showing you how the test equipment detects and displays test failures. I'll also demonstrate how not having the low limit set could result in a false pass.